This is the second video in the test 4 review, and it covers material on vectors and working with operations of vectors and dot product. Okay, so remember that a vector quantity is a quantity that has both a magnitude and direction. And so we can represent these vector quantities as a vector, which is just a directed line segment. So the length of the vector represents the magnitude, and the arrowhead on the end of the line is going to indicate the direction of the vector quantity. So there's different things that we can do working with vectors, and I'm just going to review some of that using some practice problems. So we're going to sketch a plus b using the parallelogram rule. So what we're going to want to do is take a and b and connect them so that their initial points coincide. So I'll redraw a, and then we're connecting b from their initial points. So next what we need to do is complete the parallelogram where A and B are two of the sides. So that would look something like this. So now we've completed our parallelogram. So A plus B is going to be the diagonal of the parallelogram. So A plus B is the diagonal of the parallelogram, where the initial points, we have A and B, and we use those as our sides. So again, this is just our parallelogram rule. So A plus B is going to be this line that we have in blue right here. So that is the vector A plus B. So in this problem, we're given a graph of two vectors, and we're asked to evaluate A plus B, A minus B, and negative A. So remember that geometrically a vector is a directed line segment, but algebraically it's an ordered pair. So we can write, there's a horizontal component and there's a vertical component. So our vectors can be written in component form, which would be finding the, basically it's terminating point on our graph. So for A, we would have the vector -2, 2, and for B, we have the vector 1, 2. So if we're looking at the sum of vector AB plus CD, then that's just going to be equal to A plus C, B plus D. So in order to find A plus B, we would just have -2 plus 1 and 2 plus 2. So we would have -1, 4 as our sum of A plus B. For A minus B, we would do -2 minus 1 and 2 minus 2, which would just be equal to -3, 0. And then negative A would be equal to -1 times A. So that would be equal to 2, -2. So in this problem, we're asked to find the magnitude and positive direction of the vector, or positive direction angle of the vector -5 root 3. So the magnitude, or the formula for the magnitude of a vector AB is written as square root of A squared plus B squared. So in this case, our magnitude is going to be the square root of -5 squared plus -5 root 3 squared. So this is going to be equal to the square root of 100, which is equal to 10. And the positive direction angle of our vector AB is going to be tangent theta over B equals B over A. So that's going to be -5 root 3 over -5, which is root 3. And so theta is equal to 60 degrees. So just to give a visualization of how this would work or why this is the way that it is, I'm just going to really quickly draw a vector. So if we had this vector AB, so we end at point AB, and it's our vector U, we would have, so our height here is representative of B, right? And over here we have side A. So then we also have this angle theta, so that's our positive direction angle. So if we were to solve for this angle, then we have our adjacent side and our opposite side, so that's why theta, we can say tangent of theta equals B over A, and we can solve for theta to get our angle. And remember, the magnitude then, we're basically just using the Pythagorean theorem to solve for the length of our vector, which represents the magnitude as we've previously discussed. So in this problem, we're given a graph of a vector, and we're asked to write that vector in our component form, AB. So we're sort of working backwards from where we were at with our previous question. We're given the magnitude and the direction angle, theta, and so then from there we need to find A and B. So remember that we can sort of think of vectors in terms of trig. We have this vector U, our angle theta, and then we have A and B. So A, B, and we know that B is equal to our magnitude U times sine theta, because sine is our opposite over hypotenuse, and our opposite is B, and our hypotenuse is our magnitude U. So from there we can just solve for B. And since A is our adjacent side, we can similarly say that A is going to be our magnitude U times cosine of theta. So let's go ahead and solve for our A and our B. So we've got A equals 11 times cosine of 45 degrees, which is just going to be 11 times root 2 over 2. So 11 root 2 over 2. And B equals 11 sine of 45 degrees, which is also going to be 11 root 2 over 2. So in component form, this vector can be rewritten as 11 root 2 over 2, comma, 11 root 2 over 2. In this problem, we're told that two forces are acting on a point, forming the angle 81 degrees, and we want to find the resultant force. So we can just draw that real quick. So we have this force, 390 newtons, and then we have a force of 420 newtons, and together they're forming this angle of 81 degrees. And so we want to find the resultant force. So from here we can use our parallelogram rules. So we're going to draw our parallelogram, and the resultant force is going to be the diagonal, or like the the force that divides the parallelogram into two triangles. So now we have two triangles that we can work with, and we're going to need to use a little bit of geometry and trig to solve for this resultant V. So let's work primarily with this lower triangle. So in order to solve for V, we have our two forces, right? Because we know that this side over here, that this little dashed line that we drew is also 390 newtons, just because of how parallelograms work. And we need to find V. So it looks like we're going to need first to find an angle in this triangle. So if we remember, adjacent sides of a parallel, or adjacent angles in a parallelogram have to sum to 180 degrees. So we can find this angle here by subtracting 81 from 180. So we find that that angle is equal to 99 degrees. So we now have two sides and an angle, and we can use the law of cosines to solve for our resultant force. So the magnitude of V is going to be equal to 420 squared plus 390 squared minus 2 times 420 times 390 times the cosine of 99 degrees. So we know that then that V squared is equal to approximately 379,746, and we'll take the square root of that, and our resultant force V is going to be equal to 616 newtons. So remember, we're going to use our parallelogram to create triangles, and this property right here is very important because we're not going to be able to figure out what this angle equals, but we can use sort of the geometry of a parallelogram to get this angle V, or we could also call it our angle A, where this is our side A, and we can use that and our law of cosines to solve for the resultant force. So in this problem, we're given two components and we're asked to find the dot product. So if we're looking at the dot product of two vectors u and v, their dot product is going to we've got AC plus BD. So with the dot product, you're just multiplying each of the components and finding the sum. So we're going to have 3 times -4 plus -3 times 5. So if we multiply those and we add them, we're going to have -27 as our dot product. In this problem, we're given two vectors and we're asked to figure out whether or not they're orthogonal. So two vectors are orthogonal if their dot product is equal to 0. So what we're going to do is we're going to find our dot product, and we need to see if it equals 0. So we would have the dot product of these two would be -1 times 15 plus -5 times -3. So that's going to give us -15 plus +15, which equals 0. So yes, these two vectors are orthogonal. So just in summary, this video covered material on vectors. So we have these vectors that have a magnitude, which we call v, and that's going to be the square root of a squared plus b squared, where a, b is sort of the component form of that vector, and the vectors form an angle that we can find by saying tangent of theta equals a over b. So also remember that we can do operations with vectors. We can do dot product. That's important to to just sort of remember what that looks like. And if you'd like some more practice with these, you can look at the test review on my math lab, and there's going to be one more video covering material for test 4.